Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 8, 2025, just yesterday. The standout claim is that an automated AI system can design and iteratively improve expert-level empirical software, often surpassing state-of-the-art human methods across diverse scientific domains. The paper is titled, "An AI System to Help Scientists Write Expert-Level Empirical Software," and as we will see later, the results are really impressive. In short, a language model guided by tree search explores program variations for scorable tasks, integrates research ideas, and consistently discovers high-scoring solutions. On X, reactions highlight that language models plus tree search deliver state-of-the-art on measurable scientific tasks, with favorite prompts encouraging hybrid strategies. Others note automated pipelines generating novel solutions and scalability trade-offs. Engagement looks moderate, with one post near 130 likes and several single-digit replies and likes across the collage. Alright, the previous segment set up the motivation and the range of scorable tasks. Figure 1 shows the full pipeline and headline results. A prompt combines the scorable problem with research ideas, the language model writes code that runs in a sandbox, and a tree search grows candidate programs, choosing nodes that balance exploration and exploitation so the score improves. The middle bar chart reports higher public leaderboard percentiles when tree search is used, especially with expert seeds or boosted decision trees. The right panel outlines where research ideas originate, including expert write-ups, literature summaries, recombinations, and deep research. Okay, the previous figures summarize the overall pipeline and gains. Figure 2 presents the scRNA-seq batch integration results, showing how tree search methods score against published baselines. Panel B ranks methods across datasets and metrics, where bold names with TS consistently rise toward the top because the automated search recombines ideas effectively. Panel C traces the winning BBK-NNTS improvement steps, highlighting that adding combat-corrected PCA embedding drives the big jump. Panel D compares overall scores, and recombination runs dominate many top bars. So the previous figure focused on scRNA integration. Figure 3 turns to COVID forecasting and shows how the rolling search produced a strong retrospective model. Panel A illustrates the sliding 6-week validation window that feeds each forecast period, which keeps model selection aligned with recent dynamics. Panel B ranks weekly average WIS, where cooler blues indicate improvements versus the COVID hub ensemble. Panel C compares jurisdictions head-to-head, and Panel D maps the nationwide error distribution. Panel E groups strategies, showing replications, recombinations, and new ideas that reduce error. So, the previous figure covered COVID forecasting. Table 1 compares remote sensing segmentation methods on the DLRSD benchmark. The top 3 rows list tree search solutions that reach mean intersection over union around 0.8 or higher, which signals state-of-the-art quality. The entries specify architecture choices and test time augmentation, so the gains track to strong encoders like EfficientNet V7, and extensive flipping and rotation averaging. The bottom rows summarize recent published baselines, and their mean intersection over union values fall noticeably lower. So the previous table covered remote sensing. Figure 4 compares forecasting accuracy on ZAP bench. The panels show mean absolute error across horizons, with red bars for standard time series or video baselines, and blue bars for tree search variants. The general tree search model wins for 4, 8, 16, and 32 steps because it leverages cross-neuron context efficiently, while a specialized one-step model edges out baselines at the shortest horizon. Dotted and solid lines mark mean and stimulus baselines, and error bars report 95% confidence intervals. Alright, 2 takeaways stand out. Pairing a language model with tree search turns software design into a measurable search problem, and that recipe reliably beats strong human baselines across biology, forecasting, vision, neuroscience, and math. The broader implication is faster, reproducible scientific iteration wherever tasks are scorable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.